This talk is intended to provide information that will enable the viewer to operate more safely and efficiently at the disaster site. We'll talk about how to operate the disaster site, and in addition, we'll talk about the various types of buildings and how they respond to extreme forces so that you will have a better idea of what structural configurations and hazards you might encounter. This presentation is intended to be a roadmap for understanding these basic concepts of structural collapse, and it's derived from the Structural Collapse Technician Training, which is a 4-hour presentation. And in the manual, there are over 115 pages. The manual is included on this CD, and you're encouraged to refer to it for an in-depth study. Take advantage of this kind of a presentation where you can do one of the sections and then refer to the manual to read further as you wish. And what we are going to do is cover in the PowerPoint version here the most important concepts and about the more simple buildings, the more common buildings, and then you're to refer to the manual for additional reading. So, to summarize what we're going to cover, we want you to become familiar with the structural collapse response and how to organize a site when you come to it. And then, as engineers do, we want you to understand some of the basic concepts of structure, what materials are and what forces are, but that's only important if we convey some of the important principle, which is what's a brittle material, what's a ductile material, because that tells us something about how they'll respond at a disaster site. We'll talk a little bit about building systems and how some systems have redundancy and some do not. There'll be a short review on building types and characteristics. These characteristics mostly will be explained in the manual. And then sort of for the major portions of the talk, we'll talk about in depth the causes of collapse, where we'll focus on earthquake, wind, blast, and fire. And then we'll talk about collapse patterns, where it's the engineering part of collapse patterns is to figure out where the building's going to go and where they have done, how they've collapsed historically. But for this presentation, we really want to focus on potential victim location and give you some idea of what survivable voids look like. And then we will go on to a little bit about hazard identification, what happens when you get to the site, collapse and falling hazards, and then we'll end up with the FEMA Urban Search and Rescue Marking System. So in introducing the structural collapse response, NFPA 1670 is the document that discusses and is the standard document put out by the NFPA 1670 committee, group of about 30 folks that are very well informed about urban search and rescue. We want to then discuss urban search and rescue and survivability, identify personal and on-scene safety issues, discuss incident size-up, the removal of readily accessible victims, some of the collapse warning signs, which of course are important. We want to discuss setting up incident command and some stages of urban search and rescue. And then we want to talk about so that you will understand the need for team operations and proper composition of a team for safety, and then some basic search tactics. So what is NFPA 1670? It's the standard on operation and training for technical rescue incidents, which includes urban search and rescue and other kinds of operations. It identifies and establishes the operational capability for safe and effective operations for incidents. So the purpose is to really specify the minimum job performance requirements for service as a rescuer in an emergency response agency. Again, it's developed by a committee of 30 very well-informed individuals that are involved in urban search and rescue throughout the United States. This talk is intended to focus on the awareness level and satisfy those requirements, which are on the screen. But we will be talking a little bit about some of the operational and technical levels where we will talk about collapse patterns from light frame and other kinds of structures. So this is sort of, let's call it an enhanced awareness level presentation. The theme of urban search and rescue, of course, is to save trapped victims while minimizing the risk to the victims as well as to the rescuers. The screen is a survival time versus time of extrication that is an approximation, and as it shows, the sooner that one can remove a victim from confinement, the better chance they have of survival. I wouldn't take those percentages as being anything exact, but the general drift is within the first day, one has a very high probability of survival, and after that, one has a lower probability. As you may know, this is in earthquakes, victims have known to survive for as long as 2 weeks. When we come to talk about blast, this kind of a indication of survivability is not the case. Survivability from blast is rarely more than an hour or more. Personal safety. Teamwork, of course, is very, very important. A minimum of 2 is a team where one can watch the other and one can perhaps enter a structure while the other remains outside to provide support. In urban search and rescue, of course, the team, normally the rescue team, is 1 leader and 5 rescue specialists. Team concept is extremely important. In addition to that, personal safety, personal accountability needs to be maintained. In order to minimize risk, one needs a sign-out system, an immediate supervisor. In the case of a rescue squad, it would be the leader, and then the rescue squad's leader would report to his manager. And in entering any space, one would want to have pre-planned an escape plan, as well as some idea of where a safe haven was in the confined space. We don't do any of these. We don't do any of this urban search and rescue without having a plan and without maximizing our potential for safety, essentially, minimizing our potential for disaster. Before we enter, we want to identify unsafe areas. We have a safety officer, of course, in the urban search and rescue system. However, one should know that anyone can stop an unsafe operation at any time. And then we wear, of course, personal protective equipment. One of the things we want to do in scene site safety first is control the utilities. The electric grid is normally off during an earthquake, and there are a number of examples of rescuers going into structures with the electricity being apparently off because the entire system is down, and then once they were inside, the system went back up, and of course the electricity was turned back on, and they were then searching in a building that had live wires, and that had to be immediately corrected. So one must make sure at the beginning that the electricity and the gas and all the utilities are turned off to that particular structure and space. Within the collapse safety zone, there are collapse and falling hazards. One needs to try to identify those, and at the least one needs to avoid them or minimize the exposure to them. And again, with a small team, only part of the team would enter, where the other part would be available to provide relief if necessary. In addition, there might be rescue shoring, although that depends on the victim's needs, because if the victim is not viable for more than a short period of time, one, of course, would not take the time to build shoring. One would have to take a slightly larger risk to try to remove the victim. Lighting, of course, is important, both site and personal, and we all have lights on our helmets and to light our way in confined spaces. We also want to limit vibration, and we want to limit rescue overload. By rescue overload, I mean because rescuers are so highly trained and so eager to find a victim, often there will be too many rescuers that will attempt to remove a victim and can cause overload in the general area. In addition, engineers normally provide monitoring of the structure, whereas the hazmat folks will provide monitoring of the atmosphere. So we want to adhere to all these safety kind of precautions before we deal with any kind of a confined space. Initial site size up. What one wants to do, with the way we engineers want to do it, is we want to, from a distance, move completely around the building. And that gives us some idea of what's going on, so we're not within a dangerous fall zone when we're doing it. And if we could get above the building, that would also be very helpful if an aerial ladder was available, or I know there are new little helicopters that they have that can do that if they were available. Probably not. One wants to identify then the extent of the collapse and the potential fall zones. As an example, if there's an unsupported wall that's 15 feet high, the fall zone of that wall might be 15 feet away from it. And that needs to be recognized, and no equipment needs to be put in that position, and it needs to be cordoned off, and access needs to be done from some other area. Building condition is important. Is it an old building? Is it a new building? Older buildings may have defects from aging, but what we engineers want to look at is, first of all, when we're going around the building, are the corners straight? That'll tell us whether the building is leaning, that is racked, where gravity loads are tending to cause it to overturn. The other very important racking indication would be the window openings or door openings. If they're square, that tells us one thing, that the building is still relatively square. If they're racked, that is, they've become parallelograms, that tells us that things have deteriorated a little bit. The other thing is falling hazards. Falling hazards can hurt and kill even us with helmets on, so we want to be aware of where they're coming from. In addition, one wants to remove accessible surface victims. In order to do that, one needs to question them a little bit. What's your name? Are you okay or are you hurt? And if hurt, where? And so that one would know if one needs neck and back stabilization before moving. Then what kind of medications they might take, which is something that we would perhaps want to add to the information that you're giving when you hand them off. Because once they're in your system, they're not able to, they may or may not have the adequate medication with them if they have heart or diabetes or other problems. Where were you in the building? From that, do you know of any other person in the building? So you need to determine as much as you can from the victims, keeping in mind that you have to be as tactful and careful with their psyches as possible, but nonetheless, they are your best source of information. And from that, one can plan the search tactics, and at that point, then one makes a decision about mutual aid. And the usual sort of saying about mutual aid: if there's any doubt, call them out. Collapse warning signs. We will cover this in much greater detail later, but just quickly, extreme forces that will cause the building to destabilize from where it is. Most structures that have collapsed in one way or the other are at rest. They're not stable. So that any kind of a lateral force, such as an aftershock, high winds, rain, snow, can cause them to change from their current at-rest condition to some kind of a condition of secondary collapse. And also, if the building is out of plumb or racked, as mentioned before, one already has gravity acting at some distance on a leaning object, which will tend to, there already is a tendency for the building to be forced to overturn and go to the ground. No one has ever repealed the law of gravity, and so we always have to deal with that. Gravity is very helpful to us in stabilizing things if they're straight, but once something is racked, gravity is acting against us, and there's a tendency for the building to overturn. Excessive loading on floors and roofs caused by debris could be caused by water in the case of a fire, and then one would see sagging or unlevel floors or roof, or one might find missing or broken beams or other elements. The other thing that we engineers look at would be cracks in walls, columns, and foundations. And it's not that they are cracked, but are the cracks stable? That is, are they changing? And we have methods of trying to measure that. Then separating or bulging walls, falling plaster, airborne dust. That's going to tell you that something's going on in the building, that this dust is being generated. And then sound. Building makes sounds. They creak and groan, and the sounds of distressed wood. When we test our shoring, we can hear the creaking and so forth of the wood as it is distressed and getting ready to collapse. Just a short overview on the phases of operations during a collapse operation. The 4 phases of urban search and rescue are spontaneous rescue, which occurs by those that are not hurt. Then there's light in-place rescue. Normally that is taking place by the local fire department. Then heavy, careful removal and body recovery are done by more technical type urban search and rescue teams like FEMA's teams or state regional teams. And then lastly, demolition normally is done with the aid of contractors where one has changed from the rescue mode to the recovery mode. And within the collapse operations, there are 5 stages. They're usually the reconnaissance and survey and site survey, where essentially the priorities are established by search. And then surface victim removal, void space search and rescue, and then one gets to selected debris removal and then general debris removal. Incident command system is what we all should be very familiar with. There are 2 courses, of course, on at least 2 courses, ICS 100 and 200 that are online that all of us should have taken. But to me, the most important things of the incident command system are span of control. That is that there's one person in charge of every 5, and so on up the chain. There is a unified command at the top, which allows for many agencies to participate seamlessly and efficiently. And there are well-defined functions such as search, rescue, and so forth. And there's a little on the screen is a little diagram of what a incident might look like. So what happens in incident command is that as the incident occurs, the first truck or engine that arrives will assume command. Whoever is the commander of that vehicle will assume command. He'll set up command. He'll define the limits and where the post is, his command post is. He'll look at the collapse and fall zones, which is, I've got an arrow there, which is extremely important. He'll probably establish a staging area for oncoming aid. He'll do a size up, which we've already talked about, survey the collapse, and make sure the utilities are taken care of, shut off, tagged out, and begin and define the stages of urban search and rescue. And then he'll control the rescuers and bystanders and determine the need for additional resources. This is, of course, somewhat of a repetition of what we've already talked about. Search tactics. Really, search is all phases of urban search and rescue are important, but the focus of urban search and rescue is determined by search. If we don't have live victims, then we don't have the need for rapid, relatively high-risk operations. So search defines the risk-reward ratio. And search, of course, needs both detection and location. There are elements of search or methods in search where one occurs better with the type of equipment one is using, that is detection, is better done by some of the technical equipment, where location might be better done by some other types of things like canines or individuals. There are then at least 4 types of search that can be done. Physical void search, which really should be done by trained teams, fire department teams that are well trained in confined space operations where they have an entry team and a reserve team. They will enter the space. They may or may not find unconscious victims, but at least they're inside the space and have a good chance of finding victims that are easily seen. From the top, the audible call-out search is often effective, where individuals can be organized into a grid search or a line search where they will carefully go across a site and call out and expect a response by voice for the most part. Then we get to a more technical search, which would be one where one would use cameras that could be thrust into the, cut holes for and thrust into the rubble pile or through floors, or electronic search where tapping and vibrations within the structure made by individuals is responded to or is listened for electronically. And in those systems, of course, one needs a hailing system and special equipment and special training. Lastly, we have canine search, which is a very limited resource, but the canines, well trained, are part of a team that is a handler and a canine, And a properly trained one can be directed into very dangerous areas where the humans can be kept away from those areas, and then the canine can determine if there is a need to enter that area if one finds live victims. Normally with canine search, one will use 2 canines so that you'll have a confirmation of one canine's work.